I'm back, and let's take a look at why the timings seem to be slightly off for the bell rings. And by that I mean why they trigger typically a second before or a second after the event they're supposed to. Like in this particular case, greenhouse water is off was supposed to trigger at 10 seconds, and the first bell ring was supposed to trigger at 9 seconds, yet the water off appears first. And similarly, thermostat day on setting was supposed to trigger at 12 seconds, and the second bell ring was supposed to trigger at 11 seconds. So again, the order is slightly off. So it wasn't always. That's in response to a fix I did for something else, which it did fix, and I still actually overall like this better. I'm fine with that slight difference in timing, but it might be better to go back to the original. So when I'm in the greenhouse controls class, let's just minimize this for now, and then I'm in the bell class. So here's the bell class. Public class bell extends event, implements serializable. Again, that's just so I can save the state. It extends event, this class here, so it has a start method, a ready method, and an action method that I have to implement. And where am I? And let's see. In here we've got some private instance variables. So we've got private int ring. This is just the number of times the bell should ring. This is code that I added. So look, step 4.5, that's just a arbitrary thing for me. But this little comment says when I added this code. The following code was added in response to the issue of the bell event not resuming with bell rings after the program is restored after a window malfunction or power out event. Simulated control failures. The issue only affected bell event because it's run as a separate thread, whereas the other events objects run in the main thread. Since Java threads can't be serialized, the transient keyword tells the serialization mechanism to skip this field when saving the object to a file, i.e. when using object openstream.write. So this comment's just indicating when I added this stuff. So I've got these private instance variables, current ring that tracks how many rings have completed, and public static transient, and it has to be static in order to be used later in a static method. So private static transient thread ring. The transient just indicates that this is redundant for static method now. I originally didn't have this as a static method, so transient was required. Now, because I have it as a static method, I'm just rereading this. Transient is not required, so I'll leave it in there for now just in case I change that back from a non-static method. I don't want to have to go back through that. But the transient basically just tells the compiler, hey, don't serialize threads. The transient keyword prevents serialization. I have this Boolean flag completed. Just lets me know if all of the rings have completed. Because if the shutdown happens mid-thread, I want to know, did my thread complete or not? And then is complete is just a method returns that or not. True. So this is all to do basically with the fact that I have the bell event running in a separate thread, and when the shutdown occurred, everything else was coming back online properly, but the bell wasn't. It wasn't when I restored the system. If the bell rings were mid-rings, so to speak, let's say if there was 5 rings supposed to happen, and the shutdown happened, as in our case here, the examples 3 file just ran, where the three rings happened, but the other 2 didn't. When we restored the system, any other events continued on afterwards with their appropriate delays once I got it to that point. But the 4th and 5th bell ring didn't happen because it just never went back. The thread was lost. So this was in response to that, so that way I could continue with those bell rings. This is the default constructor, the parameterized constructor. They're both parameterized constructors, correction. This one just takes in a single parameter of type long for the delay time, and this one takes in a second parameter indicating the number of rings that we can set our instance variable for. So we can ring more than 3 times, which is the default. In the action method, so this is the last thing I added, which is probably causing the issue because 4.5, this is just creating a thread It's a little, we create a thread called ring thread that basically puts the thread to sleep for 2 seconds, and then 2 seconds later the thread will be awake again, and we'll go to the next ring using this for loop, and we'll basically ring the number of times that someone entered, that the file said to ring 5 times or whatever. And this just indicates mark finish if all the rings are done. If we've rang all the time, so in the last example there was supposed to be 5 rings, when all 5 rings are complete, if current rings equals rings, then we're going to go this dot completed, which is that Boolean flag we created, we're going to set it to true. So it's set false by default, but once all the rings have happened, we've set it completed. And we're just using, this is for safety. When you have a shared resource, this just allows for safely accessing a shared resource. Synchronize this. You can also we could have made a synchronized method. There's lots of different ways to do this. And using synchronize in general is actually somewhat not considered the best coding style now. Some people, it's better just to use other methods of thread safety, but this is quick and easy, and it's fine for my purposes. But I think this is the code. The last code I added here basically says if completed, or ring thread is not equal to null and ring thread dot is alive. Basically, if the thread was completed, or ring thread equals null, which it'll equal null after a shutdown, and it's still alive, meaning, hey, there's still more stuff to do, I'm going to return. I'm not going to create a new thread. I think this might be some of the offending code. I'm not sure. Let's just comment this out for a second. We're going to do this a little at a time. Resave this. And this code I added at the end here. But I also added this at the end as well. So I think I have to change this as well. And you'll see why in a second. But I'm going to just do one step at a time. But I don't think this is going to fully solve the issue. But let's take a look. So let's rerun this again, or recompile it rather. So we just recompiled. And where's my little timer? Keep this little timer up. So we're going to run this. And that's why we had that there. We'll see in a second. So we had a lot of issues there. So that is why I have that there. Basically, yes, if the thread is completed, or the thread is not equal to null, and thread is still alive, we want to return. We don't want to start a new thread. So basically what this is doing, and why I put this in here, is, let me just look here, is because I didn't want to restart the thread every time. So this basically says, hey, if it's completed, if the thread's completed, don't restart a thread. Or if the thread's not completed, but it's not equal to null, meaning this got activated once and started a thread and assigned it to ring thread. And if the thread's still alive, which is just a function associated with threads, letting us know if the thread's still active, if it hasn't stopped, or if that's true, then return. just exit this action, because otherwise we're going to create a new thread however many times we call action, and we call action a lot. So if you recall, in the controller function, where's action here? So the abstract method action is from event, and because all, like bell event, power on event, all these events extend, all those classes extend event. And then what event does is when we run one of these things, a controller, when we run them in the run method here, we call action, which is the thing in, where am I? In the bell event, the method that we're currently in. So action method. When the action method, when we come into the run method, when we're running one of these things, we say, hey, is the event ready? Well, the event's going to be ready anytime. Well, as soon as it's ready, it's going to be ready for the remainder of that event as far as the timing. And we're going to come in and we're going to remove the event from the list, but we're only going to do that if it's a non-bell event. That only happens for events that aren't bell, and only if bell is complete. So basically, there's no issue with any other event because they come in this and we remove it right away, so they don't call action again over and over and over on the event. But for bell, because it only gets removed once the bell event was complete, this action method would get called over and over and over and over and over again until that event was done. And so say if there's 5 rings that happen 2 seconds apart, that's 10 seconds. So for 10 seconds, action is going to be called like a lot of times, like hundreds of thousands of times, or whatever the processing speed is on the computer and how fast the program is running. But as you can see, it just runs indefinitely. So that is no good. So that's why this code was added, to avoid that. So that's why I did that. Basically, hey, if the event was completed, return, don't create a new thread. Correction, if the thread was completed, return, don't create a new thread. Or if the ring thread is not equal to null, which it is equal to null when it would be equal to null the first time before we ever start the thread, but as soon as we create the thread, it would not be equal to null. And it will be equal to null, by the way, again, when the thread is done, when we call a shutdown method. So again, basically, while we're not shutting down, and while we create a thread and before shutdown, hey, don't come here if you've already created it once. And if the thread's still live, don't come here. So that's that. So that code's needed. However, this other code that I added, when I commented out this, and you can see, I said code commented out in step 4.8. Code commented out in step 4.0. So these were commented out at the same step. And this code was added. So I'm going to uncomment this. And then comment out this. And we'll see what happens. Again, file save as. And as you can see, the code that I commented out, basically I slept for 2 seconds and then I checked if thread.currentThread.isInterrupted, which is, you'll see where I interrupt it later, where I interrupt the thread in shutdown. If the thread is interrupted, if not interrupted, I print the thing out. But if it's interrupted, I wouldn't have printed that out. So I only printed to the screen, to the console, bell rings whatever number of times out of the total rings. I only printed that if the thread wasn't interrupted. Whereas now, I'm going to do this and see what the difference is. So I did a lot of this code last night, so just trying to remember. So I've recompiled the code after saving. I'm pretty sure I saved it. Can't remember now. Let's recompile it again just because I wasn't sure if I saved it. Let's rerun this code. Let's get back our clock. It's always good to have the clock going. Let's get this going like this. So we're going to run this. So let's get example 3 back here. So again, this is the contents of example 3. We'll put this back. Okay, so it seems to have worked. And why do I say that? Well, because when we first started the system restarting, the first thing that triggers is thermostat on night setting, then light on, light off, greenhouse water on, fan off. So all these events got triggered and removed from the list. Thermostat night at time 0, light on at time 2 seconds, light off at 4 seconds, greenhouse water on at 6 seconds, fan on, fan off at 7 seconds and 8 seconds respectively. Then bell rings 1 out of 5. The first bell ring happened at 9 seconds. Remember, this should have happened at 9, 11, 13, 15, and 17. So the first bell ring happens at 9 seconds before greenhouse water is off. So, which is at 10 seconds. So again, this happened. Great. And then the greenhouse water off at 10 seconds. Then the second bell ring happened. And then thermostat on day setting, which is what's supposed to happen. Because the second bell rings at 11 seconds. That happened. And then thermostat day setting at 12 seconds. Then the third bell ring at 3 out of 5 happened at 13 seconds, followed by the window malfunction at 15 seconds. And notice this is the issue I was trying to solve, and which I did solve doing it the other way, but it screwed up the timings, is I was wondering if I could not have this bell ring. But the problem is this event happens at the exact same second as this. So when this happens, even though this shuts down and prevents any other further actions, this event, this fourth bell ring, was already in the works of happening. So it rings anyway. So this happened, but then this still ends up happening. Even though bell interrupted, I'm still doing the same thing. I'm interrupting the bell, preventing it hopefully from printing out. But because of the way threads work, it's not perfect. And this bell always seems to ring, which is fine. But and then I ring it again afterwards because it got interrupted, doesn't think it rang. So let me show you what I mean by that. This fourth ring will happen again, which is what I wanted, but getting something weird happening here. So I'm running the dump out so that we can restart. So this shouldn't happen until around 15 seconds. And it happened very early, 4th and 5th seconds. And then the terminate happens at about 20 seconds. So you can see that we get that fourth ring again, the fifth ring, and then terminating. So it does what it's supposed to do in the sense that those rings. My issue that I was trying to solve was having this ring interrupted so we never repeat this. So I can solve that, or it does solve that in one sense. We can solve that in one sense by, again, commenting out this code and commenting out this code, but then we have the other issue. So it's constantly a thing of what do you value when you're dealing with multi-threading in a separate thread. This is just kind of a part and parcel. Now there are a couple of ways I could address this, which I may do. One of them being I chose to do the interrupt. I chose to interrupt. Let's just look at the shutdown method. I chose to, in my shutdown method, and again, see in step 4.8, so this is my shutdown method here, I chose to code added to address the problem that occurs if bell thread is mid-ring. This will stop it from ringing again before exit. And it did work that. If the greenhouse controls.bell, which is just, again, because it's an inner class, I have to qualify it like this. If the greenhouse controls.bell.ring thread is not equal to null, and it's alive, which is the same test I'm checking for in the bell event, then I'm going to interrupt it. So I'm going to interrupt. But the problem is that interrupts don't work perfectly. You can have issues with them, bugs. So it's not a perfect solution. It's a quick and dirty solution, and it works for the most part. It's a 90% solution, or really 99% solution. There'd be really no issues doing this. Having that bell ring, especially considering it was at the exact same second anyway, is not a problem, because that would be what it expected. If the system's shutting down the same second that the bell was supposed to ring, it would make sense that that bell rings again. And it'd be fine that we re-rang that when we started. That wouldn't be the end of the world, especially for a bell ring, because it only can happen with a bell ring. It's not happening with water on or water off or something else, which might be more of a concern if you have the event repeat itself at all. It's only happening with a bell ring. So really, I'm actually just fine whether I use this code or not. Not using it, meaning having the bells in sequential order, I think is better, and having the index to ring, this was just something I was trying. There is other ways we could do it. I could create like an interface called complete or completable, that instead of having in my bell class, instead of having this boolean completed and is completed function, I could create an interface that I could have bell extend, so I could have like bell implement serializable and also, completable or something, or just whatever, and have that have a method that complete that I override only in the bell event and no other events, and it can accomplish sort of the same. It can stop an event from running at all, or from completing, a thread from completing, and that might be a cleaner way to do it. That might avoid some of these Boolean flag thread stuff that I'm having issues with. I could try something with volatile, using the volatile keyword, which is another thread safe mechanism that's in place that might allow me to, if I create another, I could create like a volatile Boolean variable like thread running that I could start. I could activate when the thread starts running, and I could check that in my shutdown. There's other solutions I could do to try to solve this issue. I don't see any of them as actually necessary. I think the code is ready to go at this point. That's definitely something I could do. One thing for sure I need to do is get rid of a lot of these steps and everything. Dude, I've added a lot of comments as I've been changing this code, so I can probably get rid of some of this now. But anyway, that's that. So the code, as it is now, it does seem to work pretty good in my opinion. So let's just do a couple run-throughs actually. Let's just grab all the files and see if they work. That'll be our last run through. That's example 1. Let's see. Examples 1.txt. Examples 2.txt. Examples 3.txt. And examples 4.txt. Example 1. We've already did example 3, but we'll do it again for completeness. And finally example 4. And we'll see if all these work. I've been doing a lot of other testing this entire time, but these are the files that came with that we're supposed to test with, so let's just do that. Okay, so this timer should let us know what's going on as well. Okay, so we're going to run through a couple things. We're going to recompile. I don't think I've made any changes, but let's just make sure we have a clean compile. So we'll start with example 1. And I'll try to get the timer to match, but it's pretty hard to do that sometimes. Six seconds, 8 seconds, 10 seconds, 12 seconds. Okay. So let's see if we lined up appropriately. Right away we had the thermostat. Let's see if everything matched up. As soon as the program starts, we have thermostat on night setting, then light on, light off, water on, water off, thermostat on day setting, and terminating. Let's see. Thermostat on night setting, light on, light off at 4 seconds, water on, water off. We didn't have the bell happening, it doesn't seem. Bell event was supposed to happen at 9 seconds. Okay, that's a weird thing. Thermostat day setting happened at 10 seconds, and then terminating happened at 12 seconds. So all that seemed to work, but we didn't have the bell happening. And I'm just curious as to why that is. Because it should have happened right before here. Let's just run that one more time to see if it's well, first of all, let's try to run the dump. It shouldn't work because we didn't get terminated, so it should just go system restoring from file, and nothing will happen. It'll actually hang here, which is not good. Oh, bell rings 4 and 5. It's doing the last dump. So the dump, the way I have it set up is that it does, let me just show you guys, is that it does append to the end. So right here, dump out. Oh, that's not it. That's not where I'm looking. You know what? I'll search true. Okay. So when I write to the error log, I have this optional second argument when I create my file writer. Normally you just need one argument indicating the name of the file that you want to create your file writer based on. But if you pass in a second optional argument, which accepts a Boolean, it decides whether or not you append to the file, meaning you just keep adding to it, or you start over. I've chosen to append. That way I could keep track of all of my errors that have happened since we've been running the code. Same for the fix and the dump out. You can't really read the dump out actually now that I think about it, but I choose to append to the end. So let me just show you. So that's for the error log. Fix log, same thing. I append to the end. And dump out, maybe I guess I'm not appending to the end. However, it doesn't get deleted. So if I run the dump, it's going to print whatever else was already there. And the last time we did the dump, I still had 2 rings to go. So, but you wouldn't run that anyway, restore, if you didn't do it. So this is kind of an artificial thing that I'm creating here. So it's not an actual problem. I'm just showing it. What is a problem is that the bell didn't happen. So let's run this again. So we were just going on with the console. Let's run that again. Let's try to figure out why this bell event is not triggering. Yeah, I'm not really sure why that is. We'll come back to that. Let's run the other events and see if we have an issue with any of the other ones. But we will definitely have to come back to that. Let's run it for example 2. Four, 6, 7, 8, 9, 10, 11, 12, 13, 15, 17, 20. Okay, so let's see if those timings matched up. Thermostat night setting, light on, light off, greenhouse water on. So thermostat night setting, light on, light on, light off, water on, fan off, water on, fan on, fan off. First bell ring at 9 seconds, so after the fan off. There's 5 rings, so again this would be 9, 11, 13, 15, and 17. So the first bell ring happened at 9 seconds, so that would have got deleted, or that happened rather. Then water off at 10 seconds. Then the second bell ring at 11 seconds. Thermostat on day setting at 12 seconds. Oh, that keeps happening. And then the other bell rings all sequentially, third, fourth, and fifth happen at 13, 15, and 17 seconds. And the last thing that happened was terminate at 20 seconds. So example 2 seemed to work. So again, still not sure why this didn't happen in example 1. I'll just delete everything. That's the only thing that we're working on for example 1. For example 3, and there's nothing that, there's no malfunction, so again, there's no restore that we need to do. So now if we run example 3, which this one we've already done, but we'll do it again anyway. Four, 6, 8, 9, 11, 13. So my counting might be off there, but we've already seen this one go through, and everything's in the right order. Bell event is the first ring is happening before the water off. Second ring is happening before thermostat day. So again, the first ring would happen at 9 seconds before the water off at 10. Second ring that happens 2 seconds later would happen before thermostat day. So we don't need to go through this one again. You can pause it if you want, but that one works all good. We just need to continue with the 2 rings. So if I restore this, it just will finish with the 2 rings that need to happen, and then shut everything down. So the 2 rings happen, and then terminate will happen at 20 seconds. So right about now. So that one works. So event 3 works. So far we're just curious about event 1 with that bell. And finally we're going to try number 4. So again, we're expecting thermostat night, light on, light off, water on, fan on, actually water on, and then we're expecting the power out. So we shouldn't see fan on, fan off, and that sort of thing. So let's just go and see. 2, 4, 6, and we're done. Okay. So as you can see, the system starts up, thermostat on, night setting. That happened. And then light on, light off, 2 seconds. I don't know why this is 2 seconds, and light off at 4 seconds. And then water on at 6 seconds. And then we never got to fan on because the power out event triggered, an emergency power outage, emergency shutdown, happened at 6.5 seconds. So we had the water on happen right here. And then we never got fans on at 7 seconds because we had our power out triggered event. Now when we restore, we should see fan on, fan off, the first bell ring. Remember, these bells ring every 2 seconds. So we should see the first bell ring. Fan on, fan off, first bell ring. Water off, second bell ring, thermostat day, third bell ring, fourth bell ring, fifth bell ring, and terminate. That's what we should see. Should be about 7 seconds. 7, 8, and terminate about now. Okay, so as you can see, after the fix was applied, we had fan on, fan off, the first bell ring, water off, the second bell ring, thermostat day, all the other rings, and terminate. Well, that's exactly what we thought. Fan on, fan off, 7 seconds, 8 seconds, then the first bell ring at 9 seconds, water off at 10 seconds, second bell ring at 11 seconds, thermostat on day setting at 12 seconds, and then all the other rings 13, 15, 17 seconds. Finally terminate was at 20 seconds. So everything worked except for example 1, as expected, except for example 1 where our bell never went off. And why is that, I wonder? Well, what is special about example 1? Let's just take a look. Okay, so example 1, the thing that might be special about example 1 compared to the others is there is no multi-threading. So for all the other ones, bell has the optional third parameter, meaning it's ringing some certain number of times. For option 1, it doesn't have that parameter. Also, another thing that's different, well, example 2 doesn't have a power out or a window malfunction event. So example 1 and example 2 share that in common, whereas example 3 has a window malfunction at 15 seconds, and example 4 has a power out at 6.5 seconds. But the only difference, the difference between example 1, it appears, and all of the other examples, seems to be that it doesn't have that third parameter. So let's see why that might not run then. I'm in my greenhouse controls class. I'm in my bell event. And I have a constructor that, the default constructor, it's not really the default constructor. In fact, I might change that. It's like the default constructor. Typically, default constructor is like a no args constructor. This one does have an argument, but it doesn't assign any. It does still assign things to rings. It's just something I've decided, an arbitrary number, default to 3 rings. It doesn't rely on any input. But why is it not working, I wonder? Because really it should work the same. Because this dot rings is still getting assigned a number. It's just getting hard coded 3 default rings as opposed to something the user puts in. So obviously it must have to do with, it's not the bell event, but when I'm reading in the bell event, when I'm reading in. So that would be when I'm reading from the file. So I'm just going to search up part of my regular expression pattern, which is for my optional third parameter is this. So again, I'm still in, I'm in my restart event, my restart class, and in the action for this, when I read in an event, I'm basing it off of this regular expression. And the regular expression has the event, comma, time, and this optional third parameter, which may or may not happen. That's, if you read my notes, I've kind of detailed exactly how the breakdown of this regular expression is happening. And part 3, the outer wrapper is basically this, and you don't need, this is the question mark basically makes the whole non-capturing group optional. This means this part may or may not exist, but obviously it seems to be causing an issue. And I'm just going to see why. Extra param, so event. So if the event that gets read in, if the event type that gets read in is a bell, add new bell event, which takes a new bell delay comma extra parameter. Okay, it seems that I only call the default, or I only call the 2 argument constructor. I never call the default constructor or the single parameter constructor. So if there was no extra argument, this would be 0 by default, because let me show you. Int extra param equals matcher.group3 if it's not equal to null. So I'm using a ternary operator here. I'm checking this out. Hey, is matcher.group3 not equal to null? If that's true, if true, so that's what the question mark is, like if, then I'm going to go integer.parseInt matcher.group3, whatever group 3 got passed in, which is whatever the number of rings is in the file. So like, 5. Else I assign 0. So technically 0 rings was happening. Really, I can fix this a couple different ways. I could basically make it so that I add the event, and I have some conditional statement here, some if-else logic that within this case statement that basically adds the event with the single parameter bell constructor in one case when there's not a parameter, otherwise an extra parameter. Otherwise, I call this two argument version when there is an extra parameter. But that seems overly convoluted, where I can simply do this. Instead of returning 0 if this is false, meaning if there was no third optional parameter, I'll just assign it to 3. That's what I wanted my default rings to be anyway. In which case, I actually never need that single parameter constructor. I can always just do this. So this is a quick and dirty fix. I'm going to do it though, just to get this working. And now we're going to try this again. A lot of issues. I seem to be having a lot of issues with this. Okay. A lot of me fiddling around here. This is example 1 again. We're going to restart this. We're going to recompile it. I'm going to make sure I saved it first. I'm going to recompile the code. And I'm going to run example 1 again. And we're going to see if this works out. Four, 6, 8, 9, 10, 11, 12. Okay. So that did solve our issue, because as you can see, we had thermostat on night setting, light on, light off, water on, water off, first bell ring, thermostat on day setting, second bell ring, terminating. So right away, thermostat night, light on, light off at 4 seconds, water on at 6 seconds, water off at 8 seconds, first bell ring at 9 seconds. So remember, this would be 9, 11, 13. First bell ring happened at 9 seconds. Then thermostat on day setting at 10 seconds. Then the second bell ring at 11 seconds. And then terminating at 12 seconds. So terminating at 12 seconds means we've never seen the third bell ring. I could change that if you wanted to verify that the third bell would have in fact rang. We can just change this to 14 seconds. Save everything up. And do that one more time. And so again, night on, light off, water on, water off, first bell ring, day setting, second bell ring, third bell ring, and terminating. So there you go, but I'll make that change back so you don't screw it up. And that's pretty much it. So that was a long video again, showing kind of the troubleshooting steps I've went, some of the decisions I've made. Perhaps I'll do a video of me going through the whole code and actually explaining the code, but for now, that's it.